Okay, now let us continue for the next example. This one from past year, June 2015, question 4. So the marks is 13 marks. Solve the initial value problem by using Laplace transform. So now we want to solve for the second order differential equation. And you are given two initial condition. Condition for y0 equal to 0 and y prime 0 equal to 1. So for the first step, apply Laplace transform for each of the term and then simplify. So Laplace of y double prime minus Laplace of y prime minus 6 Laplace of y is equal to 2 Laplace of exponent to t. So I already bring the constant to the outside. So now Laplace y double prime, by referring to the table of the Laplace transform, y double prime is equal to s square ys minus sy0 minus y prime 0. So you have to substitute these things to the position of the Laplace y double prime. S square ys minus sy0 minus y prime 0 minus Laplace of y prime. So substitute s minus y0 to the position of Laplace of y prime. So since you have minus operation here, make it in bracket sys minus y0 minus 6 Laplace y. So Laplace y is not in the table of the Laplace transform, whereby you have to remember that Laplace y is equal to ys. So minus 6ys is equal to 2 Laplace exponent 2t. So from here, our a is equal to 2. So by refer to the table of the Laplace transform, 2 will be multiplied 1 over s minus 2. So now you have to simplify the whole thing and apply the initial condition. S square ys, there is no initial condition here, minus sy0. So y0 will become 0. This one is 0. Y prime 0, the condition for the y prime 0 is equal to 1. So this one will become 1. And there is one more thing, initial condition for the y0 is equal to 0. So therefore, s square ys minus s multiplied with the 0 will become 0 minus 1 minus s multiplied with the ys, so minus sys minus 0 will become positive of 0. So actually there is no problem if you don't want to write the 0. Minus 6ys is equal to 2 multiply 1 over s minus 2 will become 2 over s minus 2. So I just rearrange back. S square ys minus 1 minus sys minus 6ys is equal to 2 over s minus 2. So now we proceed for the next step. Simplify into ys equal to the something. So in order to simplify into ys equal to the something, we need to factorize all the ys. So ys in this big bracket, ys multiply with what? So that it will become s square. So ys multiply with the s square. Ys multiply with what? So that it will become negative s. So ys multiply with the negative s. Ys multiply with what? So that it will become negative 6. So minus 6. So the rest, which is negative 1, we just write negative 1 at the behind here. is equal to 2 over s minus 2. So now everything that you have on the left hand side here, you have to move to the right hand side. So we will move negative 1 first to the right hand side. So negative 1 bring to the right hand side will become positive 1. So for the right hand side here, the denominator is not the same thing. So you have to make it become same denominator. So 1 is over with 1. So we have to cross multiply. 2 multiply with 1 will become 2. S minus 2 multiply with 1 will become S minus 2. So plus S minus 2 divide with S minus 2 multiply with 1 will become S minus 2. So if we can simplify on the right hand side, so you have to simplify. Okay, so why we need to simplify? Because we want to make the right hand side become a compact term. So we have positive 2 and negative 2. So 2 minus 2 will become 0. So ys is equal to, so directly bring the s square minus s minus 6 to the right hand side. So this one will become the terms at the denominator. S over s minus 2 multiply with s square minus s minus 6. So now we already obtained ys is equal to the something. So now proceed for the next step. Solve inverse Laplace transform, whereby you have to write Laplace inverse curly bracket for each of the term and solve accordingly. So from ys equal to the something here, we want to write Laplace inverse curly bracket. So Laplace inverse, Laplace inverse. Laplace inverse of the ys will become yt. Laplace inverse s over s minus 2 multiply s square minus s minus 6. This one we have to solve inverse Laplace transform, which is by using rational function. Why we have to solve by using rational function? Because we have something multiply something at the denominator. So now in order to solve inverse Laplace of the rational function, we have to write this one in the terms of the partial fraction. S over s minus 2 multiply s square minus s minus 6. S minus 2 is a linear term. S square minus s minus 6 is a quadratic term, which is we have to check whether you can factorize or not. So by using calculator, this one can be factorized s minus 3 s plus 2. So now substitute s minus 3 s plus 2 to the quadratic term here. So therefore s over s minus 2 s minus 3 s plus 2. So now everything at the denominator is a linear term. So now how to write your partial fraction for the s minus 2? So this one will become a over s minus 2 plus, for the second bracket, s minus 3 b over s minus 3. For the third bracket, s plus 2, this one will become c over s plus 2. So now in order to find the value for the constant a, b and c, we need to eliminate all the denominator at the bottom side here. So on the left hand side, we always copy down whatever we have at the upper side. So s is equal to a multiply, a is divided with the s minus 2. So on the left hand side, we will close s minus 2. So s minus 3 s plus 2 will be multiplied with a. S minus 3 s plus 2 plus b. b is divided with s minus 3. So on the left hand side, we will close s minus 3. So which means s minus 2 and s plus 2 will be multiplied with b. S minus 2 s plus 2 So for the C here, C is divided with the S plus 2. So on the left hand side, we will close S plus 2. So S minus 2S plus 3 will be multiplied with C. S minus 2, S minus 3. So in order to find the value of A, B, C, I will use the method of substitute any suitable value of S. So by referring to the bracket, the first bracket here, S minus 2, S equal to 2. So that the first bracket will become 0. For the second bracket, the suitable value of S is equal to 3. For the last bracket, S plus 2, the suitable value of S is S equal to negative 2. Let S equal to 2. So substitute S equal to 2 to the equation that you have created before this. On the left hand side, S will become 2. A multiply S minus 3, S plus 2. So A multiply 2 minus 3, 2 plus 2, plus B, S minus 2, S plus 2. So this one will become 2 minus 2, 2 plus 2, plus C multiply S minus 2, S minus 3. 2 minus 2, 2 minus 3. So now simplify. 2 minus 3 will become negative 1. 2 plus 2 will become 4. So negative 1 multiplied with 4 will become negative 4. So 2 is equal to A multiply negative 4 plus B multiply 2 minus 2. This one is equal to 0. 2 plus 2 is equal to 4. So anything that is multiplied with 0 will become 0. So B multiply with 0 plus C multiply with 2 minus 2 is 0. 2 minus 3 is negative 1. So anything multiply 0 will become 0. So therefore 2 is equal to negative 4A. Therefore A is equal to negative 1 over 2. So now substitute the second value of S. Let S is equal to 3. On the left hand side, S will become 3. 3 is equal to A multiply S minus 3, S plus 2. 3 minus 3, 3 plus 2, plus B multiply S minus 2, S plus 2. 3 minus 2, 3 plus 2, plus C multiply S minus 2, S minus 3. 3 minus 2, 3 minus 3. So now simplify. The left hand side is 3 is equal to A multiply 3 minus 3 is 0. So automatic A will become A multiply with 0. Plus B multiply with 3 minus 2 will become 1. 3 plus 2 will become 5. So B multiply with 5. Plus C multiply with 3 minus 2 is 1. 3 minus 3 is 0. So C will become 0. So 3 is equal to 5B. So therefore B is equal to 3 over 5. So now let S is equal to negative 2. So the left hand side S will become negative 2 is equal to A multiply S minus 3, S plus 2. Negative 2 minus 3, negative 2 plus 2. Plus B multiply S minus 2, S plus 2. Negative 2 minus 2, negative 2 plus 2. Plus C multiply S minus 2, S minus 3. Negative 2 minus 2, negative 2 minus 3. So now simplify. Negative 2 minus 3, negative 5. Negative 2 plus 2 is 0. So therefore A will become, A will multiply with 0. Negative 2 is equal to A multiplied with 0 plus B. Negative 2 minus 2, negative 4. Negative 2 plus 2 is 0. So therefore B multiplied with 0 plus C. Negative 2 minus 2, negative 4. Negative 2 minus 3, negative 5. So negative 4 multiplied negative 5 will become 20. So negative 2 is equal to 20C. So therefore C is equal to negative 1 over 10. So after you have obtained all the constant for the A, B and C, we need to substitute back all the value to the partial fraction that you have right before this. So this is the partial fraction that we have right before this. So substitute back A equal to negative 1 over 2, B equal to 3 over 5 and C equal to negative 1 over 10. So from here, we have to write the Laplace inverse curly bracket for the whole thing. Laplace inverse S over S minus 2, S minus 3, S plus 2. This one is equal to the YT. On the right hand side, if you have any constant at the upper side, so you have to bring the constant to the front. So for the first curly bracket, bring negative 1 over 2. Second curly bracket, bring 3 over 5. The third curly bracket, negative 1 over 10. So actually you can directly bring the constant to the front and then you write the Laplace inverse curly bracket. So from here, Laplace inverse 1 over S minus 2, by referring to the table, the answer will become exponent AT. So our A is equal to 2. For the second curly bracket, A is equal to 3. For the third curly bracket, A is equal to negative 2. So therefore write the answer. Negative 1 over 2 exponent 2t plus 3 over 5 exponent 3t minus 1 over 10 exponent negative 2t. So this is the final answer for this example.